But doesn't it already have a common denominator because the index is 12?
Oh yeah, you're right. Sorry, I'm looking at the wrong spot. Yeah.
I'm really confused. Because putting them in brackets isn't just another way of saying times?
Yep. So multiply them together, add up the fractions. I was wrong, they do have the same denominator. And so we get 9 over 3. What does that equal when you simplify? M3. Okay? Okay, do the next two now. Now you will need common denominators, and I'm not lying to you this time. Okay. Did I do this one right? X exponent 17 over 12?
Yeah.
Okay. Can you simplify that anymore?
No.
No. So that is your final answer, okay? Okay, how was that? X 23 over 20? Hands up, you got that. Okay, good. Hannon, for someone who wants to sit back there, you're sure talking loud. Okay. Growth and decay. You've seen a little bit about this last year, just the very basic. So sometimes you can just caveman this, but there is an equation. By caveman, we just like figure it out, going down the numbers. So what we have is we have a starting population times an action. The action can be double, which would mean that's a 2. Or if it's a triple, that means it's, whoops, nice spelling, triple with an LE, that would be times 3. Now the time will be your exponent. You gotta be careful with the time, okay? It would actually really technically be the number of actions. And time will tell you that. So let's talk about that as we explore this first question. Okay. Population of Kelowna, it was growing crazy. It says it doubles every year. Okay. So we start with 20,000. How many in n number of years? Okay. So we can say that the population will equal 20,000. And what's the action? Doubling. Okay, this is the action. So this would be 2, and n would be the number of years that we're measuring. Okay. So this is what we call your general formula. And one of your textbook questions asks for that, or the next page. What's the general formula? Okay, that's what they mean. So use n for time. Now, let's figure out 5 years. So what's the population in 5 years? So 20,000 is the start, times 2 to the exponent 5, because we double every year. Okay, so now you can go to your calculator, or you can figure it out in your head. 32. Now what I mean by caveman is you can go 20,000, then year 1 will be 40,000, and then year 2 will be 80,000, then year 3 will be 160,000, then year 4 will be 320,000, and what about year 5? 640,000. So caveman means just figuring out the long way without a formula. Okay? And that's the technical term. It's a joke. Okay. So let's just make sure that works on my calculator. 20,000 times 2 exponent 5 equals 640,000. Okay. So the population in 5 years equals 640,000. Okay. What about 7 years? Has anyone got that yet? Do that one, please. Let's not call out. Don't want to ruin the surprise. I know how excited you guys get about this stuff. Okay, that's sarcasm, but whatever. So now we're at 2,560,000. Okay. Good. Any questions? Okay. Turn it over. Okay. So underline the important information, please. Read it and underline the important stuff. So what do we start with? What number? 12. What's the action? 2. Now, how many times is that going to occur in 17 days? How many times will it get doubled? Once. So our exponent will be 1. And that's the trick there, right? How many groups of 17 are in 17? 1. So technically, please write this down. 12 times 2. Really, it's 17 over 17. Right? How many groups of 17 are 17? 1. That's why we get the exponent 1. Okay? And that's going to be more important for the next question. So 12 times 2, which equals 24 bugs in 17 days. Okay? Okay, do B now by yourself, please. So our fraction now will be 34 over 17. And some of you hopefully did that, but some of you probably went and said, well, that should be 2, right? Because it's going to double twice. Okay, so either or is fine, but it's good to understand as a fraction so that that 2 exponent makes sense. Okay, and so it's going to be 12 times 4, which is 48 bugs. So now there'll be 48 bugs. All right. Bugs.
Bugs is a funny word.
It is. It bugs me. Bugs me. And little Bugs Bunny. I mean, he's not a bug, he's a bunny. So why are you calling Bugs? Okay. Because he bugs. Okay. What about this? 17 days ago. What kind of number would represent the past?
17 days ago from 4?
From the beginning.
Zero.
No, 0 represent no days, no change.
There's less.
Alfredo, you're wrong. 17 days ago, what kind of number? Oh, Kaya, brilliant. Okay, negative. Okay, so what we're looking at, as a fraction, it would be negative 17 over 17. So she's saying that should then be a negative 1 exponent. Which is kind of cool because what do we do with negative exponents? Turn them into fractions. Now it's a positive 1 exponent, which means we're taking 17 and multiplying it by a half. We're finding half of 17.
Why is it half of 17? It should be half of 12 because there's 12
Oh,
bugs.
did I screw that up? We start with 12 bugs. See, there you go, Pinto. Well done.
And then it should be
The rest, boo. Okay, 12, 12. So we're finding half of 12, which is a much better number. So there was 6 bugs 17 days ago. Okay. Could you caveman that? Probably. You take 12 divided by 2. Okay. But I like the exponents. More elegant. Kind of like me. Okay. How you guys doing? Okay. You okay, Evan?
Yeah.
Okay, a new car loses about 10% of its value per year. It's called depreciation. So what's the value of a $32,000 car after 5 years? Bingo! So what we're going to do is take 32,000. If it loses 10%, how much is left after each year? 90% left. So we're actually going to multiply it by 90%. And this is going to happen how many years in a row? 5. So let's just see how much your fancy new car is worth now. Go to your calculator, find the number. And this is why you don't buy a new car, folks. What do you want?
Not a partner number.
0.9 exponent 5 equals times 32 G's. $18,895. Yep, and 68 cents. As soon as you drive the car off the lot, it's like boom, 10% gone, just like that. That hurts. At least it does for me. I ain't made money.
You ever bought a new car?
You waste the money, waste the money.
Sure. You never bought a new car.
No, my first car, it was a blue Chevy Cavalier. Yeah. It had a bumper sticker on there for my stepmom, half ripped off. Let's not get into details. No.
Well, now you have to tell us.
No, I don't.
Start the stream and stop.
Oh, yes, I can.
No.
Anyways, it was a 4-door car, so it's a family car, and I didn't care because it's actually a stick shift, which is kind of cool. Hard to find. Oh, you'll find out one day. Yep.
Rebecca, what did the bumper sticker say?
Sorry?
No, because you already took away the...
Sorry, what did you do? You took 15%?
No, like,
Yeah, go ahead.
5% goes down every year for 5 years.
Yep.
And then there's 50% of the value left.
The original value.
So 32,000, you take away 3,200. What is that? 28,800? Is that it? Someone calculator, what is it? Quickly! All you guys. 3200 minus 3200. 2880. So here's the thing though, Gagan. Then you take 10% of that, which is 2880. So you're actually subtracting a little bit less. And that's why you can't do what you did. Okay? Because it's just the weird thing with depreciation, because you're taking less and less each year. And we're going to talk about with graphing, that looks like this compared to that. Okay? And that's going to be later on term 2. Okay? Whereas appreciation is like that. Okay? For you art fanatics. Okay. Pause it.